Hello, I hope everybody can hear me. So, thank you so much for joining us tonight, and we really appreciate your presence. This is a special live webinar that we're trying to use to get ourselves to learn more about art. So, it's not a kind of a, a broad topic, but it's really specific to R, and we're targeting those who are just coming up learning R. So we're looking at using this means to help ourselves. And we're really honored to have Dr. Kenneth Enwerem, an epidemiologist and a special person that is really passionate about R, to take the lead this week. So without taking much of our time, I'd like to introduce him more so that we'll get to know who we're really here to meet. Our special person tonight is this popularly known R. Mallam, is Dr. Kenneth Enwerem, who is a seasoned medical doctor, an epidemiologist with over a decade of expertise in humanitarian emergency program management, a community health planner, and also is a professional within the disease surveillance community profession. So currently he's serving as the Senior Surveillance and Global Health Security Officer at the Institute of Human Virology, Nigeria. Dr. Enwerem leads critical public health initiatives, including vaccine coverage mapping and integrated disease surveillance research. His work spans across priority diseases, outbreak responses, and operational support to the Nigerian Center for Disease Control, positioning him as a key player in advancing public health security. So he's a certified data analysis instructor with applied EP, that's EPI US, and Omega Cares Consult Nigeria. So Dr. Enwerem brings extensive experience in operational research and data management. He has facilitated impactful health interventions across several African countries, refining his expertise in data analytics, field epidemiology, and program evaluations. With advanced training in R programming, statistics, GIS, and infection prevention, he is a leading facilitator for the upcoming data science training, offering unparalleled insights into leveraging analytics for impactful decision making in public health. So please join me in welcoming Dr. Kenneth Enwerem, the popular R. Mallam. So, Doc, you have the floor.
Thank you very much. Can everyone hear me?
I think we do. I can hear you.
Can
Please,
you hear
you
me?
can
Can you hear me?
please you can confirm if you can hear him in the chat, or you can speak.
Yeah, but Bilkisu, can you hear me?
Yes, I can hear you.
Okay, awesome. I was beginning to wonder who you were introducing.
You're the one. It's a detailed research.
Okay.
Okay.
Okay, thanks
Yeah.
everyone for joining. I think we should just go straight into the business for today. I'm just going to share my screen. Please let me know when you can see my screen.
Yeah, we can see your screen.
Okay. Please, can other people respond? Can you hear me and see my screen? Can any other person apart from Bill Kiso respond?
Yes, sir.
Okay, awesome. That's good. Okay. Thanks everyone. I know this is taking your time, very precious weekend time for this. But I believe this is going to be very impactful for us. So the title of this webinar today is working with dates in R. I think you guys should agree with me that dates are one of the very challenging things when it comes to data analysis. So having your dates correctly and claimed will lead to a more accurate and insightful analysis. And if you are unable to get your dates correctly worked up, it will mess up the whole thing. Okay, so without further ado, let us go into this. So I've just been able to craft like a structure to to the the presentation this evening. We're just going to look at general quotes to produce dates, and then we're going to look at using conversion of date columns in our data sets to a date class. We're going to do that under 4 different approaches. We're going to use the as date function from base R, and then we will also use the lubridate functions, and then we'll look at Excel dates. Excel dates have some peculiarities when you import them into R. And then finally, we're going to look at messy dates. Then the last thing we'll do is just to do a practice on a demo data set that I was able to make to see how we would put all of this learned knowledge into practice. Okay, so let's just move ahead. So in R, I want to believe that everyone here should have some fair knowledge in R, so that you can be able to follow what we're doing. So R works with functions and packages. A function is like a tool that R uses to perform a specific task, whereas a package is like a collection of functions that perform similar tasks. So that is the work brain of R. It works with functions and packages. So what we're seeing from lines 9 to line 13 are some functions that R uses to produce dates variables or dates objects. So the function system.dates, sys.date, will actually give us the current date of the system you're working on. So for example, if you look at my cursor, I'm pointing towards the lower right corner of my laptop. So if you look at that here, you see that the date here is 13/09/2025. That's 13th of September 2025. So this code that is sys.date, if I run it, it will give us the date of my laptop or the date of today. So I'm just going to run it, Control Enter. If you look at the console here to my right side, you can see that it gives us the date, which is 2025-09-13. Now, the usual standard way R gives dates is in the format like this: year, month, and day. So this is the standard format that R gives its dates. So if like I said, when I run the code on line 11, you can see it gives me today's date, which is 13th of September 2025. And then it can further give you both the date and the time. So by running system time or sys.time, so if I run the second code, you can see in the console, it gives us both the date, which is 13th of September 2025, as well as the time now, time now is 7:50 West African time. Okay, so that's what the sys.time function does. So these first two functions are within the base R package. So they are base R package functions. So let me just write it here. But again, R has a package called lubridate, which also has similar functions that can produce the same thing that the base R functions produce. In R, we used to say that there are several ways to kill a rat. So it depends on the trap that you want to use to kill your own rat. So there are several packages in R that have functions that perform similar tasks. So it just depends on the one that you're used to and the one that gives you the answers you require at that time. So another package in R called lubridate has functions that can perform these similar things. So if I want to find out today's date, there's a function called today in lubridate. So if I run this, you can see in the console, it also gives me today's date, which is 13th of September 2025. Again, watch that the standard way that R gives its codes is the year, hyphen the month, and then hyphen the day. Okay. Then if I want the time, there's a function called now in lubridate, which performs the same thing as this system time. So I can just ask it now. If I run the dates, sorry, that function, you can see it has given me both the date as well as the time. Okay. Then the last thing is date, which is another function. It gives you the system date and time with the weekday and month names. So if you want the weekday in words and the month in words, instead of using today, you use date. So if I run date, you can see it gives me the weekday, today is Saturday, the month in words is September, the date is 13th, and then the time is 7:53, and the year is 2025. So that's what the date function gives us. Okay. So again, I want to emphasize again that all dates in R are given in this format, in the format year hyphen month hyphen day. Okay. Are we together up till this point? Can everyone still hear me?
Yes, sir. We can hear you. I can hear you from this end.
Yeah.
Okay. Okay. Thank you very much for that. Okay. So, okay, awesome. So now, after we convert columns to a date class in R, R usually stores those dates in its back end as numbers. It stores it in its memory as numbers. So even though we see it as a date in this front end, R doesn't store it as a date at the back end. It stores it in its memory as numbers. And this number is the distance from that particular date to the origin of R. R started in 1979, 1st January. So any date you put into R will subtract it or find the distance between that date and this date of 1979 and store that date as the number of days between your particular date and this particular date it has. Does that make sense to us?
Yes.
Okay, so that's actually how R stores dates in its memory. Even though it displays them to us as dates, it stores them as numbers. And why it does so is so that it can be able to use those numbers to make calculations. So that's why it stores them as numbers. Okay. Now, let's move to conversion to date class. So there are several functions in R that we can use to convert a date column to a date class. Now, when you see a data set that has dates, they might not really be in the date class. You might be seeing them as dates, but R is not seeing them as dates because the format in which they are or the structure of that column is not a date class. I'll give you an example. So there is a data set I have. If I go almost to the end here, I'm just going to import this data set. Okay. And then I'm going to view it. Okay. So if you look at my screen, you can see, I don't know if my screen is quite visible. Okay. So if you look at my screen, you can see that there are different dates. This is a data set that has about 7 columns and has about 20 rows. You can see it has 4 date columns. So this column of date of onset, it might appear as date in our eyes as humans, but R may not be seeing it as date. So if I run a function called glimpse, which shows me the class of each of these variables, so my data set is called patient. If I run this, if you look at this, R is not seeing these dates of onset as a date class. It's actually seeing it as a character or string. Can you see that?
Yes.
Can we
Yes.
appreciate this? Okay. So R is not actually seeing this as date right now. It's seeing it as character. This next one, date of report. R is not also seeing it as a date. If it was seeing it as a date, it will write date here. But it's writing CHR, and CHR means character, which means it's seeing it as a string. So when we import a data set into R that has date columns, we definitely should run this glimpse function to look at if R is seeing it as a date or not. Because if it's not seeing it as a date, it's not going to calculate or make analysis with it as a date. So before it can analyze that column as a date, it has to see it as a date column, and which is part of what we are here today to appreciate. Yeah. Okay. So we said one way to convert a column to date in R is to use the asDate function. The asDate function is a function from the base R package. So you just put in that column inside of the asDate function. So I'll just take an example. So let's assume I have a date. So I use my asDate function. Let's assume I have a date that is 13th 09 to 2025. So because this date is in parentheses, is in quotation marks, sorry, R is seeing this now as a character. It's not seeing it as a date. So, but if I run this strings with the asDate function, R will convert this one to enter. Excuse me. Can you see the outcome it gave? Is this supposed to be the correct date? Anyone?
No, sir.
No, sir.
It's not right. Good. So the as date function actually has a what's it called now? Has an argument where you tell R what is the format of the date it's trying to convert. So I'll put in a comma here and say format equal to, and then I'll tell R the format in which this date is. So this one is a day. So I'll put percentage day and then put in my slash. And then this one is month. So I'll put in here percentage month and a slash. And then this is year. So I'll put in here percentage year. Now notice this day is in small letter, month is in small letter, but the Y is in capital letter. And that's because we're trying to tell R that it is the 4-digit year. If it was a 2-digit year, we would have made it as a small letter. Okay, so if I run this one now, excuse me, Control Enter. So can you see it has now given me the correct date because I have told R the format in which the date I supply to it is. Do we get this part?
Yes, sir.
Is
Yes.
this clear? Okay.
Yes.
So that's assuming the date I'm supplying is in the month, day, and year format. Let's assume I supply a date like this as date. And then it's in the, let's say, month is August, day is 20th, and the year is 1998, for example. So I'll have to tell R the format in which this is. So I'll say format equal to, can anyone try to give me the format of this one? Can anyone try?
Okay, so this one will be percentage M slash percentage day slash percentage Y.
Very good, slash percentage Y. So I'm telling R that this date I'm supplying to it is in this format. So if I run this now, if we enter, you can see it gives me the date as 1998, August 20th. Okay. Let's try the last one. So let's assume I supply a date like this. 2020 0 3 10. Can anyone give me the format for this?
Percentage Y.
Very
Format
good.
is equal
So that
to
will be percentage Y.
slash percentage M.
Okay, so because in the date it's not slash this time around.
Okay.
You can see here is hyphen. So we need to use the same separator. So dash percentage M dash percentage D. Okay. So if we run this, Control Enter, you can see it gives us the date as 2020-03-19. Okay. So that's how to use your as date to convert your date class, your date column, sorry, into a date, into a date class. Okay. Are we together on that?
Yes, sir.
Okay. So let's move ahead. Let's look at the next one. So lubricate functions. So lubricate has made some major improvements in the way we convert to date class by improving on some of the weakness that as date has. So instead of using all of those formats equals this, format equals that, lubricate has made different functions such that we don't need to supply format. The formats are already embedded in the function. So for example, let me just bring these things here. Let me copy this and take it down to lubricate. Okay, let me bring it here. So for example, this date right here is in the day, month, and year format. So if I wanted to use a lubricate function to convert this to date class, what I will do is that I'll use a date, month, year function, which is this one, this DMY. So what I'll do is I'll say DMY, and then I will put in that date. So let me just copy this one from here and paste it here. So can you see the format is already in the function? So this is day, month, year, and our date pattern is day, month, year. Okay. So if I run this, it will give me the dates. So can you see the date? So it gives me the correct date because I use the function that is in that format. Are we together on that?
Yes, sir.
Yes.
Okay. So what date format is this highlighted one here? Hello, anyone?
Yeah, month, day, and year.
Okay, month, day, year. Very good. So which function should we use to convert this one?
We are using the
Second to the last.
fourth. Yes, that's the fourth.
Very, very good. So we're going to use MDY because the date format is in MDY. So we use MDY, and then I'll just copy the date from here, and then I'll put it in there. So if I run it, so you can see it has given me the dates correctly as a date format. Okay. Then the last one, what date format is this one?
Year, month, day.
And day.
Year, month, day. Exactly. So if I wanted to convert it to a date class, I'll also use a year, month, day function. So that would be YMD. And then I'll just copy this and put it in there. So when I run it, it will give me the accurate date, right? So you can see that the lubricate functions make it easier than using the as date functions that you have to specify the format because the format have already been specified in the function themselves. Are we together on this?
Yes, sir.
Yes, sir.
Okay, so that's how to use your lubricate to convert your dates to a date class. And see the different date formats that lubricate has. So just once you're able to identify the format in your date, then you use that function to do that. Okay, so the next thing is that sometimes when Excel, because most of the data that we import as a data analyst, we import from Excel into R, and then we'll try to use R to make the analysis. So when you store dates in Excel, just like in R, Excel also keeps those dates in memories as numbers. Okay? Even though we are seeing date format, when we look at it, in Excel's mind, those dates are stored in numbers, right? And they are stored in numbers. You know, when I talked about R, I said R stores numbers based on their distance from 1970, 1st of January. But for Excel, Excel stores numbers based on December 30th, 1899, if you're using a Windows. But if you're using a Mac, it stores it based on January 1st, 1904. So any date you put into into Excel, Excel will subtract that date, or will subtract this December 30, 1899 from that date, and will store the number of days in its memory. So that's how it is. So when sometimes we import Excel data into R, R will import the data as those numbers that Excel stored. Instead of importing them as dates, it will import them in those number formats. So let me show you an example. So look at this date of admission here, right? You can see that even though it's date, the values appear as numbers. Can you appreciate that? So these numbers are the number of days between the dates that we're supposed to see and December 30th, 1899. That's what it means. And that is how R imported those dates into R. Does that make sense to us?
Yes, sir.
Yes,
Very.
sir.
Okay. So sometimes when you import um, Excel dates into R, instead of them appearing as dates like this, they will appear as numbers like this. So our data cleaning will now be to convert these dates, these numbers, back into the proper dates. And that is what we're going to do here next. So in order to convert them back into the dates, we will need to work by using the asDate package, or the asDate function, to convert it and tell R that CO, these dates should be calculated from the origin of Excel, which is December 30th, 1899. Okay. So this code gives us that template. However, we must ensure that that date is in numerical form, because even though R imports those dates, even though we are seeing numbers here, R may not be seeing this as numbers. R may be seeing them as strings or characters. Again, if we run our glimpse, we put in our data set, you can see that this is the column, right? Date of admission. Here, R is seeing it as numbers, because this DBL means numerical. Because if I ask for the class of that column, patient, and then date of admission, you can see R is seeing it as a numeric variable. However, sometimes R may not see it as a numerical variable. In that case, we will need to first of all convert them to numerical variables before we can now use the asDate function and origin of 1899, December 12th, to now convert them to a date class. We will see all of those when we go into our practice. But just so that we can have that at the back of our mind. So I'll give you an example. So let's do an example. So see this number here on line 124. So this is a typical example of how an Excel date may be imported into R. So we want to use the as date function to convert it to a date. However, just like we use format to show R the format of a date when we use the as date function, in this case, we're using the argument origin. So we're telling R, this number, we want to convert it as a date, but let's you start from this origin. So it will calculate. So this number means the number of days from this date. So it will add this number of days to this date and give you the current date. So if I run this, you can see in the console that the date is actually 20th of October 2013. So this 20th of October 2013 is 41,567 days from December 12, 1899. Do we understand that?
Yes, sir.
Okay, so that's how to convert when R imports these things as numbers. This is how to convert them back to dates. Okay. Any questions on this so far? Okay,
Excuse me,
let's
sir.
proceed.
Excuse me, sir.
Yeah, please go ahead.
Yes, sir.
Go ahead.
Why the variation of these dates? The origin.
Why did,
Yes. As you said, if you are
sorry,
using Mark,
can you say that again?
I'm asking why the
Okay,
variation in
okay, oh,
these dates, the origin.
okay. I'm not sure, but I think because Windows is older than Mac. So
Okay.
when Windows was made and Excel was made in Windows, it was way back before Mac came into being. So that's why for Windows it's 1899 December 12, while for Mac it's 1904 January. I think it's because Windows goes ways back before Mac.
Okay, thank you.
You're welcome. Okay, so the next part we'll do is messy dates. So sometimes in the same column of your data, you can have dates in different formats. For example, you can see these dates. You have number here, you have words, and then you have year. The month is in words. In this case, the month is in figures. In this case, the year is only 2 digits. So sometimes you can have in one single column of dates, different formats of dates in that column. And that is where our function pass underscore dates comes into play. So you can use pass underscore dates, which is a function from the pass dates package to actually work when you have dates of different formats. So I'll give you an example. So we're going to create an object called my dates, and it has dates of different formats. You can see it has dates this type, it has this type, it has this type, it has this type. So it has different formats of dates here within one single vector. So I'm just going to create that object, and then I will now use pass dates function, which is from the pass dates package. Now, why we are writing the package in front of the function in this case is that in R, there are some instances where a function might be in two different or three different packages. So in that case, when you use just that function name, R might not understand which of the packages you're talking about. So for example, this pass date is available both in the pass dates package and the read R package. This function pass underscore date is available in the pass date package and the read R package. So if I didn't include this pass dates double colon here and I run this, R will be a bit confused and not know which of the pass dates I'm talking about, whether it's the one in pass date or the one in read R. So in such instances, we usually have to put the package name first and then put a double colon to indicate the function name. And that is how R sorts out that problem. Okay. So we've created an object called my date. So if I want to view that my dates in the console, I can just write my dates and then I will run that. So you can see in the console, it prints out those different dates formats for me. You can see that. So now I'm going to now use the pass date function to work on that object. So we'll run the code on line 143. So can you see R has neatly converted all of these different date formats into the standardized date format. So that's the powerful advantage this pass underscore date has. It can combine all of the different date formats together and produce a neatly standardized format for each of those dates. Is that clear to all of us? Hello.
Yes,
Can you
sir.
guys still hear me?
Yes, loud and clear.
Okay. It's all right. So we've seen how to convert to date class using 4 different formats. We've seen, first of all, using the as date function from base R package, where you have to put in the argument format. We've seen the lubridate functions where the format is already incorporated into the functions. We've seen when dates are imported as numbers in Excel, how we can use the as date function with the origin argument to convert them to proper date class. And finally, we saw how we use the pass date function from the pass date package to convert when you have dates of different formats in a single column, and then you want to convert them to a proper date class. I use this. So we're just going to do a small practice using our data set, this data set that I imported called patient. So again, it's a small data set of 20 rows or 20 observations and 7 columns. You can see it has ID, sex, age, date of onset, date of report, date of admission, and date of discharge. Okay. Now, if you look at these dates, so we initially had run the glimpse because it's always good to use your glimpse to find out what the current class of each of those variables are. So you can see the date of onset is a character or a string. The date of report is a character or string. The date of admission is in a number, is numerical. And then the date of discharge is a character. So what we want to do is convert all of this to a date class, right? At the end, we want this to be date, want this to be date, want this to be date, and this to be date. Okay, so let's look at it. So look at this date of onset column. Look at the dates in it. Can you guess what format these dates are in? Anyone?
MDY.
MDY. Do we all agree? Are they in MDY?
Yes.
No, is
MDY.
DMY. DMY.
So which are we choosing? Do we say they're
D
MDY or DMY?
DMY. DMY.
DMY.
DMY.
DMY.
Yes.
Okay. So they are day, month, and year. So if I wanted to convert this to a date class, can anyone guess how I'm supposed to do that? What function would you suggest I use?
As date.
Sorry?
As date.
Now we'll go for the past date.
Okay. So you can actually use any of them, but let's see how we can use each of them, right? So if we use the as dates, now the column is patient. We'll put a $sign to select. So it's date of onset that we're interested in. Okay. So what do we need to add to this?
Format.
Very good. So we're going to add format equal to what?
Percentage.
So equal to percentage day slash percentage M slash percentage Y, right? Okay.
Yes.
So let's run that and see what it gives us. So can you see it has neatly converted all of those dates to actual date class? Okay. Can we see that?
Yes, sir.
Yes.
Okay. So if we wanted to use the lubricate function, what should we use? So since they're in day, month, year, we'll use the DMY.
DMY.
And then we put in the column, which is patient's $sign, date of onset. Okay. If we run that, you can see it has also converted this for us. And then if we use our past dates, so I'm going to use past dates, double colon, past date. Again, patient's $sign, date of onset. And we run that. You can see again, it's neatly converted everything to the date class. Okay. Are we good on this?
Yes, sir.
Yes, sir. Yes.
Okay. Awesome. So let's look at the next one. The next one says date of report. And if we see, we have different combinations of date format in here for this date of report. So what function do you think we should use to convert that?
I think this is where
Past
the
date.
past date will be more appropriate.
Past date, exactly. So we do our past dates and then double colon, past dates. Our column is patients, $sign, date of report. Okay. So if we
Please,
run
sir, is
this,
the past date from lubricate package?
no, it's from the past date package. That's why I put it this here.
Okay. Thank you, sir.
Yeah, you're welcome. So you can see that past date has made all of the dates. You can see what it was before. This was what it was before. This date of report. You can see different patterns of date are inside date of report. But when we use past dates, it has converted all of them to normal standardized dates. Is that okay?
Yes, sir.
Are we together? Okay. So the third date column is date of admission. And you can see R has imported all of them as numerical numbers. So what function do we use to convert this date of admission to normal date? Anyone? Hello, can you hear me?
Yes, sir.
Yeah, so what function
We,
can we use to
we, we
convert
have
this one to normal date?
we have to use that one with origin, sir.
Very good, excellent. So we use our as dates, right? Our column is patient's $sign, date of admission, okay? And then we'll tell it the origin, since it's from Excel, is what? 1899, 1230, right? So if I run this, so can you see all of my numbers have been converted to normal dates? Does that make sense?
Yes, sir.
Okay, very good. So the last column, let's look at the last column. So if you look at this last column, it has both dates and numbers. Can you appreciate it? Sometimes when you import data from Excel, it might come in this format. Now, this one is a bit tricky because it's not just numbers and it's not just dates. So it has numbers and dates. So we'll have to approach it in a way that we'll have to incorporate changing numbers to dates and changing this date formats to date. Now, I don't know if you guys use the tidyverse way of work, but that's what I'm going to use. So I'm going to write a long code here, but just follow me and I think you will understand it. So in the tidyverse way of writing codes, we usually start with our data set. So we'll do our patient, which is our data set, and then we will pipe it into, sorry. So we want to make a change in the date of what again is that now? Date of discharge column. So I want to create a new column. So I'll call it date of discharge underscore clean, for example, equal to. Now, I want to first work on the ones that are numbers, right? So for the ones that are numbers, I will use a code to help me detect numbers. So there's a function called string detect. So I'm saying R from the date of discharge. I want you to detect any value that is in number. So I'm going to put in this. It's a bit complicated, so just follow me. Sorry, I'm dealing with numbers, so just digits plus, and then close it with the $sign. Okay. So anywhere that it detects numbers, I want it to convert it to as dates, date of discharge from origin 1899-12-30. So this will take care of the ones that have numbers, right? Then again, I would say where is the code now? Sorry. Where dates of discharge. What am I doing? I'm sorry, this is a bit. So mutate this. Oh, sorry, I forgot. I forgot my case when. Yeah, that's why I'm having error here. So case when. So again, string detect. So this next code now is detecting those date formats. So date of discharge. Again, I'm asking R to detect dates. So I'll write the dates like this. So the first slash /D. I'll explain this once I'm done. And then slash, again, /D 4. And then we close with our $sign. So whenever I detect this, it should convert. So what format are the dates here? This is day, month, year. So convert using your DMY.
Sorry, I think there might be a typo error there.
Okay. What type of error?
Where you have string underscore detect date of discharge, the second to the last line. You have /D open brace, the closing of the two.
Okay. Yeah. That's a curly bracket supposed to be there. Thank you so much for that. Okay. So I think we're done. Let me run this and see. No, it's giving me errors. Watch. The second one is error. Uh-oh, it didn't convert the numbers. What mistake did I make in numbers as dates? Oh, I see. The numbers are in characters, so I need to convert them to numeric first. So I need to convert this to numeric first. Okay, I think we should be good now. Yeah, awesome. Okay, so I know this is a bit complicated, but let me try and explain what I did here. Okay. So from our data set, patient, we use a mutate function, which just means create a change. And then I wanted the change to be in a new column. So I call that column date of discharge underscore clean, so that I can differentiate it from date of discharge, right? Now, we use our conditional function called case when. So case when, we say, so if what case when does is it gives a condition and then it tells us what to name that condition. So case when, this is the condition. This is the first condition. So what it says is, from that column that is date of discharge, I want, if you detect any string, any numbers. So what this, is this backward slash now or forward slash? I think this is backward slash. This backward slash and D and plus means is if it sees any digits, any number that is digits. So D plus just means any amount of numbers between 0 and 9, it says. If it sees it, it should convert them to date using as date function. But remember, I told you that it needs to be a it needs to be a number. But if you look at, let's look at that glimpse again. R is not seeing them as let's do glimpse. Patient, yeah. So if you look at this last column, date of discharge, even though there are numbers in here, R is not seeing it as numerical. R is seeing it as a character. And this as date, using the origin, works on numbers. So we needed to, first of all, convert it to number using as numeric. So once as numeric converts these things to number, then as date will now work on it to trace it from this origin. So that's what this first part is. Then the second part is that all again from that date of discharge, if it detects any date format, so you can see this thing I wrote here, this is like saying two numbers and then slash two numbers and then slash four numbers, which is like saying day slash month slash year. Did we get that? Hello, everyone.
Yes, sir, it's clear.
Yes.
Okay, so that's what
Yes.
this thing means. Yeah, it just says two numbers slash another two numbers slash then four numbers. So if it detects any value that appears in that format, it should use the DMY function to convert it to a date. So that's how it ran, and then it gave us this column, date of discharge underscore clean, that has converted all of those dates to a normal date class. Okay, so what I'm going to do now is to write one single code, like a pipe chain that will work on this entire data and convert all of my data of my date columns to a class, to a date class, right? So I'm going to start. So I'll store it as an object and I'll call it patient underscore clean. and then I'll assign that.
Sorry,
Okay.
I didn't get what you said,
So
sir.
yeah. No, I said I want to write a long pipe chain that will incorporate all of our cleaning functions, all of our date cleaning functions, so that we can convert all of this. You know, we had done them individually. Now I want to incorporate everything together in one pipe chain of code. So we start. So I'm going to assign the eventual output to an object name called patient_clean. So these are our data set, patient. So we start from the first one. The first one is date of onset. Date of onset is in the DMY format. So I'm just going to say mutate date of onset equal to, so I'm going to use a DMY to convert it to date of onset, to convert it to date class. And I'm done with that one. And then I'll pipe it into, the next one is date of report, which is the one that has those different formats of dates that we use pass_date. So I'm going to say mutate date of report equal to pass date, and then date of report. So again, we're done with that. And then I'm going to pipe it again into the third one. The third one is date of admission, which are those ones that are in numbers. So I'm going to say mutate date of admission equal to as date, date of admission, and then origin equal to 1899 1230. So I'm done with that. And then finally, I'm going to say, so I'm just going to copy this last one from here.
Please, sir,
Copy
can you
this.
clarify this use of origin, please, sir?
Okay, let me just finish this and then I'll do that.
Thank you, sir.
Okay, so this code, this entire code now will work on the entire data set and give us a cleaned date of each of those columns. And then it will store the output in this patient_clean object. So if I run this, and we have our patient_clean here. So if we look at our patient, so these are former data. Patients, these are former data, the one with the messy dates. Now, the patient_clean, you can see, oh, we have some error. Okay, so sorry, I had done this in a new column. Let me work on it in the old column. So I just change this _clean here to discharge. Okay, so I'll run this again. So you can see our patient_clean data sets has all the dates have been cleaned, standardized, and converted into dates. Okay, as against the former data set which had messy dates. And we appreciate the difference between the two of them. This is the new one. This is the old one that had messy dates. And this is the new one with the standardized dates. Now, if I run the glimpse on our new data set, so if I do glimpse and then patient_clean, you can see now the dates are now in the date class. Can you see that? You know, before they were character, DBL, character, but now they are a date class. Okay? Are we together?
Yes, sir.
Yes, sir.
Okay, so someone asked that I should comment again on the origin. So sometimes when you import dates data sets from Excel, right? And they have date columns. Sometimes R imports them as numbers, just like you see under this date of admission. These were dates in Excel, but R imported them as numbers because at the back of Excel's memory, it stores dates as numbers. So sometimes when R imports those data, it actually imports those numbers. So when it does that, to convert it to a date class, you need to use the asDate function. Then you put the name of that column. So our column is patient, and then $, date of what again now? Date of admission.
Date of,
So date of admission. So, but we need to tell R that these numbers, they are from Excel, and the Excel stores its date with an origin date of 1899 December 12th. Sorry, December 30th. So we now say, comma, origin equal to 1899 12/30. This date is the date from which Excel stores all of its dates. So any date you store in Excel, it will store it as a number, which are the number of days from this date. Right?
okay. Yeah.
So that's how.
What
So if
what
I
if
run this now,
what if it happens that maybe we forget this date? Is there any other way, like a default for the
no,
origin?
you
Maybe
have to
we,
remember
we must remember
you
it.
have to remember the dates.
No bypass.
Yes, you have to remember the dates. So it's that's the date Excel stores dates from. So you have to remember the dates. Yeah. Okay. So that's where we're stopping for today. So we've seen how we've been able to convert this messy dates in our data sets with different formats, and converted them to a very clean and standardized dates that R can now use to make analysis, to draw charts, and all of that. Yeah. Any questions, comments, clarifications before we call it a day?
Yeah, hi Ken. Good evening.
Yes, sir. Yes, sir.
Okay, so no, we'll be looking forward to the link for the recording. My network has been in and out. I've been thrown in and out multiple times. That we can study more.
Okay, so Dr. Bilkisu, who is the host, will take care of that. I'm sure of that.
Okay, no problem. We're going to share the link. We are going to share the recording to everybody that registered. We have your emails. We'll send it to you. We're going to send it. I'll also collect
Thank you.
the code from Doctor. I'll collect the code as well. So we'll
Yeah,
send everything to you.
I'll send this messy data set, and then also this script that we've used for the class today. I'll send it to Bilkisu so that she can share with the team. Okay. Any other?
So, do you have questions?
Yes, sir. I have a question. Okay, so my question is, if I want to like export this clean data to Excel without copying it, how will I do it, sir? Thank you.
Okay, so if you want to export it, we'll just come here and say export, which is from the real package. So let me just write the full thing, real package, and then export. So you write the name of the object that you saved it as, which is patient_clean. comma, and then in quotation marks, you write the name you want your data sets to bear. So let's assume I want to say is Abuja underscore R underscore group data set, for example. That's what I want to call it. And I want it to be stored as an Excel. So .xlsx, right? So when I run this, it will appear in my file. So just watch on this right hand side. Once I run this now, you see this data set here, Abuja R group here. It will appear in this place where my cursor is. So let me run it. So Control Enter. So can you see it? Abuja R group data set. So this is the file. So if I go to where this file is in my desktop, where can I how can I get to it now? How do I take this thing away? Okay, good. Can you see my screen? No. Can you still see my screen?
We're still in our studio. Yes, we can see
You're
your
still in our
screen. We're
studio, right?
still in our studio. Yeah.
Can you see this folder?
Okay, we're seeing the, yes, we can see the folder now.
Yeah, good. So can you see the Abuja R group data sets where my cursor is? Where my
Yes,
pointer
sir, we
is?
can see it, sir.
Yes, sir.
So if I click it now, sorry, if I open it, it will open the cleaned data set. So can you see the clean data set?
Yes, sir.
Yeah. So that's how you export it from your R into your folder, and then you can have the clean data set.
Okay, thank you so much. So the Abuja R underscore group is just the name you want to call the data set, sir.
Yes, you can call it any name. Yeah, I just called it Abuja R group data set. Yeah.
Okay, sir. Thank you, sir.
Any
So do
other
we have any
question?
more questions?
Okay, so if there's no other question, thank you guys. I appreciate your time to be here. I believe we'll still have some more topics in the near future to
Okay.
work on. We'll keep you updated. Thank you very much, Dr. Bilkisu.
Okay.
Over from
Okay.
me.
Thank you so much. Okay. Thank you so much, Doctor. We really appreciate your time and support. We're really glad to have you here. Thank you, everybody, for joining us. We look forward to maybe next week or in 2 weeks' time, we'll be diving into the aspect of machine learning. So you look forward to that. We'll share the poster, and we'll also get the time and all details across to you. So thank you, everybody. For this session, we're going to share the video, the code, the data set, everything will be sent to your mailbox. Thank you very much. So bye-bye.
Bye.
Bye. Thank you.
Thank you,
Bye-bye.
Dr.
Thank you, Dr. Kenneth.
Thank you, Oga Mallam.
Good night, everyone.